What is up, most distinguished patrons of this channel? Today we are going to be dealing with a age-old welder's trick, and that is preheating mild steel increases penetration, or at least that's the theory. And like everything in this world, relying on stuff you read on the internet or from your buddy without verifying is probably not too smart. So that's what we're going to be testing today. Let's get into it. So if you're no stranger to welding, you more than likely have heard that using a torch or some other means to preheat steel, thicker steel, increases penetration. And this is so common that I can't count how many comments I've gotten on this channel where people say, well, you should have preheated that, you should have preheated it, or rather than using a more powerful welder, you can simply preheat the plates and that solves everything. And I actually already did a video regarding this, looking at the feasibility of using a 140 amp MIG welder to weld 3/8 plate by preheating it. And I'll put a link to this in the description to that video. But truth be told, in that case, no, you really can't use preheat to make the welder magically have penetration on thicker plates. But I thought, based on how many people, I'm not joking, at least 50 in the last week and a half have commented something related to, well, just preheat this. And I'm here to tell you that preheating is not a miracle worker. And that is why my apprentice, who's been working with me, by the way, shout out to Owen if you're watching this, thanks for helping me with this. But him and I decided to sit down and do a bunch of tests regarding this and figure out what the hell is really going on. And I gotta say, this is probably one of the more interesting results that I have seen doing all of this testing. Now, no, what you're gonna see today is not an absolute conclusive of everything because it's a small sample size, but we can definitely determine if there's trends and if there's significant differences. We can definitely smoke them out doing this testing. But I gotta say, the results are interesting and it's kind of what I expected. Now, I will share the results here in a minute. I'm just gonna go to the old magical board and give you a little bit of an insight of what's going on here and why preheating might not be the smartest thing to do and when it's required. And then we'll look at the results and talk about those. So I've covered a lot of videos kind of dealing with the science behind welding, but I definitely need to do more regarding that. But I'm going to give you a quick overview of kind of the theory of preheating. Certain materials absolutely require preheating. A great example of that would be a cast iron with high carbon content. And what happens is on those types of materials is if you don't preheat it, as the weld that gets laid down gets super hot, the material gets hot, and then it drops in temperature extremely fast. And that drop can cause cracking due to the amount of movement or the stress that's placed on that material. And another good one would be aluminum. If you take cold aluminum and heat it super hot in an instant and then let it cool super fast, so you blast it with heat and then let off, it will also crack. And in the case of aluminum, that's called hot shortness or hot short sensitivity. And that is why by preheating the material up to a stable temperature, anywhere between 200 and maybe 600-700 degrees, depending on what kind of material you're welding, it's not going to drop as fast in temperature and it'll drop slower, and that will prevent that cracking. So preheating is absolutely a necessity with certain materials. I've also proven on this channel that if you try and weld material at -16 to -20, that even mild steel can suffer brittle welds when that material cools fast. So absolutely preheating matters. The problem is I think a lot of people rope all of the special uses for preheat into something that is a game changer on normal mild steel at room temperature. And I think the theory really comes down to, if you do a normal, say, MIG weld, you're going to have very minimal penetration and your weld's going to be something like this, right? With very little root fusion. And if you heat it to 400 degrees, magically, your weld is going to somehow penetrate into here better, and you're going to create a stronger weld or a stronger joint, mainly because you have more fusion in there. And that's the theory behind preheat. Now, in the previous video I did on this, I didn't really see much evidence that would suggest this at all, and it didn't give a 140 amp MIG welder the capability of welding 3/8 plate, in my opinion. It did very little at, I think I did like 500 degrees in that video. So again, preheating, I think in certain circumstances is not only a must, but it's reasonable to do, of course, but using it without understanding what's going on mild steel may not be getting the results that you think you're going to get. Besides what I mentioned, the other thing that I want you to understand, and here's a poorly drawn depiction of like a fillet weld or an inside corner or something. One of the things you got to understand is when you weld on something like this, your arc, be it stick or MIG, is actually traveling through molten material. And that process, be it MIG or stick, can only penetrate so much of that before you just don't penetrate. And that's one of the issues with short circuit MIG on thick plate, is that when you try and weld and carry enough heat on that thick plate, you're more or less, your heat in here near the root is so low that nothing fuses in here, okay? So with short circuit, it's a really bad problem. That's why you have like spray arc and dual shield, and possibly even C100 gas helps with that. But that will increase root fusion. Same thing with stick. Now stick, you tend to weld through less of a molten puddle because you use a drag angle, and that does help penetration to a certain extent. But again, you're still welding through molten material. And when you preheat the plate, that's not changing the dynamic of what's going on here at all. Therefore, it's, in my opinion, I wouldn't expect to see increase in root fusion. You may see an increase in sidewall fusion where that weld will bite more into the sides, but as far as actual penetration into the root, that's more or less a limit of the process you're using, your travel speed, and the shielding gas you're running in the case of MIG that controls that, not so much how hot the plates are. And the last thing, and I almost forgot to mention this, preheating has severe limitations. Just as I proved in another video, if you weld on super cold steel that your weld will be weaker, if you weld on super hot, mild steel, that molten puddle will take so long to solidify that the grain structure of that weld will be poor, and it will also be weaker. So preheating, to 500 or 700, that might be within the ballpark of what would be acceptable. But if you get that plate to like 900, 1,000, 1,100 and try and lay a weld on that thinking that you're able to weld that thick plate, more than likely that weld is going to stay so hot for so long that the grain structure is going to be poor, and you just produced a poor, weak weld. So those are all things to consider. With that said, let's look at all of the test setup that we did, and let's look at the results. So my apprentice Owen and I both did a test plate. I believe this is mine, this is his. And what we did is we did a weld on this cold, then we torch heated it to 500 in the area of the next weld, then we welded it immediately, then we torch heated it to 750, welded it immediately, and then torch heated it to 1,000 degrees and welded it immediately. I thought I would involve him with this to rule out the issue of bias and maybe how I weld a particular rod at an amperage. So we both use the same material, the same amperage, and our different skills played whatever role it's going to in it. Now, I did the same thing with the fillet welds, except he was the only one that welded them, and we did 125 amps, and we did 500 degrees, we did ice cold room temperature, so probably 60, and then we did 750 and 1,000 degrees. And we did a cut and etch on all of this, and the results I think are going to intrigue you or at least be of interest. So let's take a look at those right now. Here we have the flat plate that both of us welded. The number 1 was done at room temperature, and then it progressed up hotter, and number 4 would be 1,000 degrees Fahrenheit. So let's look at the cut and etch of these. We'll start out with my side, which is on the left there. So the coldest weld was the number 1, and number 4 was when the plate was super hot. There's a couple things that we can determine from this. One, as the plate got hotter, the welds tended to spread out more, so much wider. And I can tell you, actually welding these, that when I got up at that 1,000 degree one, more or less, it just seemed like a pool of molten metal was flowing out flat. It didn't really seem to me like it was biting in much. Now the angle of this photo is a little bit bad to determine depth of penetration. I'll have a better one coming up. But looking at this, to me, the penetration on the cold plate and the super hot plate are about equal. Maybe the super hot is a little bit better, but 2 and 3 really, I would argue, have less like depth of penetration. The profile of it is wider and more rounded, which is good. So sidewall fusion would probably be better on a fillet weld, but the actual depth of penetration isn't really better on 2 or 3. And you got to remember, 3 was 750 degree preheat. Nobody preheats their material that hot, like 1/4 inch, 3/8. I mean, you're going to have to sit there with a torch for quite a while, and I seriously doubt anyone's doing that. And 1,000 degrees, my guess is at that point you're going to start suffering weld grain problems due to how hot that plate is and how hot the weld is. On flat plate, the overall look of this, again, I would say is not pointing towards the general direction that, for me personally, I would see increase in fusion with hotter plates, but this is just a bead on plate, so there's a lot more to look at. Now let's look at Owen's test plate. So this is Owen's plate, and 1 obviously is the coldest, 4 is the hot plate. When we look at these, and you can't really see 1 very well, but it basically has identical depth of fusion or penetration as number 2. So 1 and 2 are about the same depth. However, much like mine, we can see that as the plate got hotter, the weld flattened out a significant amount. Now, the interesting thing is his number 3 doesn't have very much fusion or penetration at all. That might be because his travel speed picked up. And once again, 1 and 4 seem to be the best in his case as well as mine. And I noticed that his welds look a little bit different than mine, and that has to do with just differences in the consistency of movement. He has a tendency at lower amperage to do a slight circle, or not really a circle, but a little bit wider of a bead than me. I run stringers that are just in line and that's it. So that likely also played a role. But again, all things considered, we're not seeing some magical increase in penetration by preheating plates. I mean, if you were to cut this open, maybe 20, 30 of these welds and look at it, I don't think that you would be able to make a determination on what was preheated and what wasn't. I mean, if anything, the 750 seems to be the worst in both of ours, but again, there's not like some miracle going on here where it makes a massive difference, at least on flat plate. Now let's compare both his and mine side by side. I apologize for the crappy picture here. Anyways, I drew a line on the top one to kind of gauge the depth of penetration. The bottom plate there is at a different angle, and I couldn't get a line that I felt was an accurate representation, but you can kind of use your own eyes to gauge this. But when we look at the top plate, which is mine, the depth of penetration on all of them is virtually the same. I would say 1 and 4 are the best, then 2, then 3, or somewhere around there. But it's not like night and day different. We can tell that the plate was preheated for 2, 3, and 4 simply because the welds are flatter and wider, but that's it. There is no increase in penetration. Now, number 4 has a wider area of fusion than number 1. There's no question about that. We could achieve the same thing that you see in 4 had we stepped up amperage to a certain extent or went to a bigger rod like a 5/32 7018 instead of the 1/8 inch that we were running. Comparing Owens to my plate, our 125 amp run, the number ones, look very similar. You can tell that he runs a little bit wider of a pass than I do just by how wide it is, but they're the same height, very similar penetration. Mine is actually a little bit better penetration than his, and again, that's likely because I ran straight in a stringer. Our number twos are basically identical. His has a little bit less penetration, but for all practical purposes look the same. Our number 3 at 750, again, very similar, very poor penetration, very odd bead profile. And then our number 4s are very similar yet again. And like I said, the number 4 at 1,000 degrees Fahrenheit preheat, nobody's going to heat 3/8 steel or 1/4 inch steel that hot to weld on it. I almost guarantee you. So to me, that's pretty much pointless, nor should you really do it. So as far as preheating helping the depth of penetration, I would say that's busted on flat plate. As far as helping sidewall fusion, I see evidence that would support that. So that's plausible. So now let's look at the fillet welds that Owen welded up and see what's going on with those. Here's a picture of the room temperature weld. For some reason, I didn't take a picture of the one with a 500-degree preheat. It looked kind of like this, just a little bit flatter. So let's look at the internals. Now this picture is somewhat misleading due to the angle, but to the naked eye, they look very, very similar. Now the 500-degree preheat has a little bit more penetration or more or less sidewall fusion into the upright plate, but the room temperature has more in the bottom plate. So it's kind of a horse apiece right here. If I had to pick a more perfect bead profile between the two, I would say that the room temperature I like better simply because it's more consistent in fusing to both of them. Now, as far as root penetration goes, it's a little bit difficult to see, but they're basically identical. A lot of what you're seeing where that rounded edge of the upright plate is, where it looks like a lack of fusion, it really isn't. It's just that I didn't mill flat that edge. And because it wasn't milled flat, there's going to be a little bit of inconsistency weld to weld there. But realistically, in person looking at these, they look very, very similar. And if I did 20 more of them, they're all going to vary about by this much. So realistically, a 500-degree preheat, I don't see any smoking gun here that is magically a lot better. Like I said, we could claim that the upright plate is better, but then again, it lost at the bottom. So not a whole lot to write home here. Let's look at the hotter plates. So here is 750, and we can see that it definitely is flatter. Now there may be some undercut at the top toe line because we just knocked the slag off, which was pretty difficult to get off, and we didn't wire wheel it or anything and just went straight to cut and etch. But this is kind of acceptable looking, although like I said, I'd worry about undercut. Now let's look at the 1,000-degree. So now this has one of the weirdest bead profiles I've seen. It's almost like a pear shape. So there's likely undercut at the top, but the bottom of the bead, it just slumps out a lot. And you'll see that in the cut and etch. But this definitely is not a profile that you want to see. It is overall flat, just rounder and fuller at the bottom than the top. To give you an idea of how hot that was, this is what it looked like immediately after welding it. And keep in mind, this was at 125 amps. So the whole thing was like bright red, and the end half, so the second half, was literally almost still molten when it was done. And it was kind of funny because the back side of this was glowing almost as much as this is that you see here, which would make you believe that you're like penetrating right through that, you're about to melt through the whole steel. But when we look at the cut and etch, it tells a completely different story. And I think you're going to definitely like this one. So let's look at it. So the 750 degree looks much like the room temperature plate. It just has a little bit more fusion in the upright plate, but the root fusion at the bottom isn't really anything better. You can see it's not really a lack of fusion, but you can watch that line on the bottom plate, and it kind of really didn't punch in there that much better, I would say. Again, the upright plate is a little bit better. Now the 1000 degree one, which that sucker was glowing red that you would think would have melted halfway through that, more or less just melted in the upright plate and barely stuck to the bottom. Now this could be because Owen favored the top plate due to how much that molten metal, that molten pool was sinking, so that might have something to do with it. But again, even at 1000 degrees, it's not like punching in there and fusing the plates together far deeper than even room temperature. Neither one of these are like a miracle in comparison to the room temperature. And I can tell you that 1000 degree, it's going to be almost impossible to weld on something that hot like normal mild steel. So nobody's really going to do that anyways. Well, let's look at all of these combined in one picture. Based on what I'm seeing here, the preheat is not allowing the weld to punch in deeper into the root and get better root fusion. However, it does appear that the preheat is allowing some more sidewall fusion. But again, keep in mind the room temperature at 60 versus the 750 degree one, which is the lower left, both have the same amount of sidewall fusion in the bottom plate. So again, this isn't like a miracle worker that we're looking at. Not that I think that preheating is a myth and it doesn't have an effect. It's just that I think that guys will sit with a torch or something, preheat steel, weld it, and they see how much hotter everything looks, and they believe that they're getting more penetration than what they really are. Because again, how many people actually test what they're welding? Very few do a cut and etch of their own work ever. And another way to look at this situation is to take a plumbing torch, a little propane one, and heat up this 3/8 plate, and you would make the plate glow. So if you heated it up long enough, it'll glow red and you're getting it hot. But would it actually fuse anything together? The truth is probably not. So really what we have going on here, I believe, is we're able to get the plate hot, but the root fusion is a direct result of the welding rod, the amperage, the travel speed in the case of stick welding, and we're just not achieving more penetration because more heat doesn't matter unless that heat is at the root of the joint and it's hot enough to where it actually fuses and it melts the metal, not just makes it glow. Hopefully that makes sense. So let's go to conclusion. So does preheating help? My opinion is, obviously in cases where you have to do it, like castings and sensitive materials, absolutely you should do it. When it comes to mild steel, does it help? Well, sidewall fusion, yes. Actual root fusion, root penetration, not so much. Does it make stronger joints? Well, I would honestly say that the difference is probably less than most people would think. Now, the interesting thing regarding this, and I haven't covered it before in this video, is that preheating with a torch can burn off contaminants on the surface like rust and oil and grease, and that might actually be a positive towards welding something, because if you were to burn off all that paint and all that junk off of it, then put a weld down, it might be a cleaner, stronger, better weld. But as far as just blatantly increasing root fusion or penetration, no. I would say that preheating it to a reasonable temperature is not going to make much of a difference at all. And it certainly isn't going to give you the ability to take a 140 amp MIG welder or some undersized stick welder with a 6013 rod and give you the ability to weld 1/2 inch thick or 3/8 steel. So that's the way I see it anyways. Now, as far as if you have been preheating stuff your whole life, should you change? Probably not. And I'm going to put this out there. One of the things is this steel is a known entity. It is A36 mild steel, more or less, hot rolled, right? When you get into thicker steels, it's pretty common, like say on a tractor or a dozer or something, that steel might not be just plain mild steel. And in such cases, it might have a sensitivity for going to super hot to cold, which is exactly what you would do when you were to weld on it when it's cold. So preheating thicker steel might actually be doing you a favor if it's some kind of an implement or something that could possibly be higher strength alloys. It would be doing you a favor instead of like on mild steel where it's not really going to do you much. Okay, and if you do it too hot, you're going to have weld weakness issues. And really, when you think of it, the preheat has nothing to do with penetration or fusion. It's more or less just to deal with the properties of the material itself. Now, I know this test result is a pretty small grouping. If you guys think that this needs more of a look at, I would definitely be willing to sit down and do a bunch more fillet welds like this, brake test them, and do further testing to kind of absolutely wring this out. But at least for the time being on this, I think that I can put this to rest, that preheating is not going to be buying you much. And if you don't have a powerful enough welder and your cut and etches aren't showing proper fusion, I seriously doubt that preheating at even the 500-600 degrees is going to make much of a difference. So with that said, hopefully you enjoyed the video. Until next time.